Adam, did you want to do introductions, or did you want me to take that, or?
If you want to go ahead and take it, that's fine.
Oh, okay. Welcome everyone. Again, apologies for the technical difficulties there. I'm Sean Wilson. I'm the treasurer. The secretary for Halifax Makerspace. I think we have a little more than a dozen people on here. So welcome. If you're not familiar with Halifax Makerspace, we've got a location in Bedford, and we offer tools, space, and sort of community to people who like to make stuff. We are currently recruiting members, and we do what we can to support the maker community in Halifax. This is one of those kind of outreach things that we've done now that COVID is kind of poo-pooed the normal stuff that we used to do. Maybe at the end of this, if there's interest, I can do like I'm at the space now, so I can do a little walkthrough, but I'll leave that to the end because I know some people have already seen it, and just to give people a chance to hop off if they're not interested in that part. But at the end, maybe I'll just see if anyone's interested, and I can do a quick run through if you like. I think this is our third show and tell. We've got another one coming up the last Tuesday of March. And we'll be looking for speakers for that as well. Just 5 or 10 minutes on any projects that are on the go or completed. You can share photos or whatever as you go, and we'd love to see what you're up to. I think I'll start things off really quick with a new initiative that we have here at the Makerspace. Since COVID, we've had a little dip in membership, and we've been unable to do workshops. So we were looking for basically something we could do to supplement our income. And one of the things we're about to try now are personalized cribbage boards. The reason we went with cribbage boards is they will sort of leverage the things that make this makerspace special. So we have a laser and CNC mills, which are capable of making really precise things. With cribbage boards, there's been a proven interest in it. Here are 3 of the cribbage boards that we've made at the space, different members have made. And additionally, I've been just selling them as a sideline for myself, and there seems to be an interest around here. So we're hoping that we can sell some personalized cribbage boards and kind of get us through the COVID slump. The other thing it leverages is our volunteers. So we've got a lot of members who are looking to help out in some way. And it's not always easy to know how to do that. So this is something we can divide amongst half a dozen people or so to split up the work. The process of making cribbage board, there's a bunch of different ways you can do it. Here at the Makerspace, we often use something called Inkscape, which is a vector-based graphic software. It's similar to Adobe Illustrator, would be kind of the next closest paid, expensive piece of software. Inkscape itself is free. So we use Inkscape a lot for our laser, and we use Inkscape a lot for our CNC mill. The hardest part of creating a cribbage board, generally speaking, is the hole spacing. If you have a complex shape, like this is Nova Scotia, where it sort of goes left and right, sharp turns and not so sharp turns, that can be difficult to space the holes out and have them look good. But with this kind of oval design, that was a fairly easy hole spacing for this board. Once you have your file laid out, you need to change it to, or convert it using CAM software, computer-aided modeling software, that basically creates the instructions that the CNC mill or the just the CNC mill, I guess in this case, will follow. And there's a bunch of different CAM programs out there. This one that I just used for this is called Open Builds, and you see that the oval shape from the previous screen on this screen is in red, and you see there's a number of, they're kind of stacked. There's 8 of them, I think. So when you're using the CNC, you take a little bit off at a time because you don't want the bit plowing through a bunch of material. So you kind of do nice gradual passes, generally speaking. In this case, that's the stack of red ovals there. And then this big mess of green on top is where the CNC would be traveling from hole to hole to drill the holes for the cribbage pegs. And with this board, I think there's about 360 odd holes. So you can tell from that big mess of green up there that it's not optimized. So I wrote a little thing in JavaScript that will take those unoptimized holes and optimize them. So in gray here is the unoptimized holes, and in yellow, after passing it through my code, is the sort of optimized path. It's to the point where it's optimized enough for me. If you were like a computer science major, you might shudder a bit to look at that, but it's to the point where if I was to invest any more time in trying to optimize it, I probably wouldn't get that time back. So as it stands, it went from about 51 meters of just traveling to about 2.2 meters, and the 2.2 meters will still take 20 to 30 minutes probably to mill the board. So if I'd left it at the 51, it would have taken hours and hours. And if you multiply that by the, hopefully dozens of boards that we're going to sell, you'd have days and days of extra milling. There we go. So the process for creating these is you start with, in my case, 3/4 inch maple, which is about the cheapest hardwood you can find locally that looks good. You mill the board. You mill the top side of the board, which cuts out the big oval, like the outside, and drills all the holes. Then you flip the board over and you mill a pocket in the back for the cribbage pegs. And then there's a bit of woodworking, just manual, old-fashioned woodworking. You route the edges because when it comes out of the mill, the edges are all sort of 90 degrees. So you just round them over so that it feels nice in your hand, looks good. A lot of sanding. We've got a lot of sanders here at the Makerspace. I don't know, 4 or 5 different types of sanders that help negate some of that work. But there'll still be a little bit of hand sanding after all that. And there's a little bit of Dremel work on the back to put basically the slot that the metal tab slides in and out of to hold the cribbage pegs in place. I generally do that with the Dremel, although I could do it with the CNC, but it's usually not worth it because it's such a quick thing. A few coats of lacquer, and then some finishing touches, which are like cork feet on the back. The metal slidey bit, and putting the pegs in place. We print the pegs here on the 3D printer as well, so it's pretty much all done here except for the lacquer, which I'll do at home because we don't really have a good spray area. And then the idea is we can do all of that stuff to produce these blanks, so there'd be no customization at this point. And then we can produce a stack of blanks, have 10 blanks or whatever at a time. And then the idea is once we receive an order, we'll be able to take one of those blanks and turn it around very quickly to get a customized board out to people. And that process would just be the order comes in, we mock it up with the person's last name, send it to the client. They can send it back if if there's problems, and we can do that as many times as we need to. We pop it into the laser, and there's probably 20 or 30 minutes of engraving, and then we just have it ready for pickup. So that's the idea. Like I say, we've got half a dozen or so volunteers, I think, who've volunteered to do different aspects of that. So it should make for everybody should have a fairly. So I'm doing some testing on it this week, and hopefully within a week or so we should be able to start selling these. So that's it for me. I think we might save the questions for the end. I think that tends to work a bit better. So I will pass it on to the next person here. Is Joel here?
I am. Is my audio working?
It is indeed.
Excellent.
Just
Everything worked out this time.
let me know. Just say next slide or whatever to let me know, and I'll for them.
Sure thing. So yeah, this is two projects really that they just happen to overlap a little too much in my life. The first one started at the end of October. The second one in early December. So next slide. All right. Oh. There we go. Okay. Yeah. So yeah, these SLA. This is a project that I used sealed lead acid or SLA batteries. So they come from replenishing server room UPS units. These batteries are old. Most of them are well past the 5-year life cycle, but they still otherwise function. The ones that were non-functional were set back aside for recycling as per what they normally were set aside for to begin with. Next slide. There were multiple considerations in mind with the arrangement of this. One of the constraints had to do with the wire gauge. You want higher voltage if you're going to use thinner wire gauge. When I consider a reasonable cost of a charge controller, there was different scenarios with that. Want to be able to minimize the cost of outputting the power itself, and that limited me to about whether it be 12 volts, 24 volts, 36 or 48, and just reasonably fit the space that's actually going into. I had an old 5U rack that I gutted about a year ago that I got off surplus. And I was using it as a storage drawer up until this point. So based on the way when I started thinking about this project itself, I was like, yeah, I could just arrange that and this and actually work it that way. I ended up choosing 36 volt DC arrangement. It's a bit exotic. The step-down converters and inverters still came to a similar cost as 48 volt, which would have been the other candidate, which I would have went with. But 48 volts wasn't going to arrange all that well inside this box. So I bundled each trifecta together to be able to extract each easier. Just a little bit of strap that I wrapped around each as I taped each of the three together. And I used 10 gauge wire to connect in between, even though that's overkill. Because there's about like 10 centimeters of wire distance between each battery in the group. That did allow me to build 4 in parallel. On paper, I could pack 8 in this space, but it's doubtful I ever will. the realistic maximum would be 6, but I'm not sure what kind of continued access I would have to old batteries anyways. Next slide. So I picked away at this, preparing the cabling for a couple of weeks. It's mostly made up of XT60 connectors, those matching yellow ones in the middle of the box, for example, as well as blade quick connectors. I temporarily layered the components and installed banana plugs one afternoon, which is kind of cut off on the left-hand side of the photo. And what I did was I fed it through what used to be the VGA port on the server itself. Late into Friday night, I mounted and connected everything. There was a white faceplate that I set up. Was a quick design with thin wood strapping behind. It's not well secured, but for the interest of this project, my motivation of it was already waning at this point. And another consideration, because of the batteries are in that kind of old space itself. I used double throw switches so I can have banks in operation. So one of the groups of 3 or 2 of the groups of 3 or whatever. One or more getting a readout through the banana plugs. We'll check them independently, and also have any combination of them also just be shut off entirely. Next slide. The charger itself is a Juntech multi-point powered tracking solar charger, which I cheated and powered it off a laptop power adapter. The 7210A, that's the model of that charger. It's a boosting charger, so my input needs to be always be voltage lower than the batteries themselves. It's counterintuitive when you go to look up multi-point power tracking or MPPT chargers, but it does make those kind of efficient chargers inexpensive as well. So that's kind of how I went with that decision. There is enough already configured here to charge as well as discharge with a cigarette lighter DC port, which is located between the switches itself and the charger. And for example, I was testing with a portable air compressor for my air pig. I just keep that with it at this point. I wish to add in an inverter, but my other project is already a better candidate for that. Really had to finish it at the point that I did, because otherwise I was just going to lose the motivation to do anything more with it at all. Next slide. Because as alluded to in the last show and tell, I had a tack welder assembled for this battery project. I had purchased over 250 new old stock 18650 lithium cells from the United States, and I just had to shuck them from the casing that they're in. And these battery packs are also built for 36 volts. Next slide. I laid them out back in December and was mostly waiting for the tack welder, and actually the bed supply I get that I'll be using with it. In one of the evenings, I tacked the nickel strips to the cells, and one of my 2 freaking moments happened near the end of that night when a strip landed in the wrong spot. It caused a short, but I was able to frantically flick it off with only a minor burn to my thumb and a small drop in voltage. It was rather jarring. And I was already on edge at that point of the evening because of the way that the Kapton tape just untacks when it just sits around where when it relaxes and changes the temperature. So that was, I was already on edge a little bit at that point anyways. Next slide. All right. So I assembled the rest a couple of nights later. A BMS or battery management system, or I'm probably getting the acronym wrong. It's a must-have for lithium, just to make sure that no part is being overcharged or undercharged. There are little wires that's included each step of your series connection to make sure to measure between each series. So that way, if one of the series is getting more voltage than anything else, then it's going to take note of that. Thanks. And it also just has the temperature sensors that you would insert as well. So if anything of concern happens, the BMS would just shut everything off. And so once I wired that up, I shrink wrapped it with a piece of Lexan in the larger one. It's actually not, can't really tell in this photo just because documents in the wrong slide. But if you actually go to the previous one, yeah. So yes.
Sorry about that.
No worries. The two larger, the two halves there. You can. I stacked them on top of each other, but I had a sheet of Lexan in between, just to just to have a little bit extra barrier. You can also tell that with how some of the upper cell, the top of the cells don't have the Kapton tape, because I wasn't there at that point to put the BMS wires on. And the way I actually just folded it over when I continued the series, just wrap around to continue. So it's a kind of weird setup, really. Anyway, so I'll go back to the other slide there. Thanks. So anyways, yeah, so once I, sorry. Yeah, so I shrink wrapped it, and I did notice I wasn't fully aware of how this sort of stuff works, but once heat gun starts shrinking it, that stuff shrink wraps really fast. It's really hard to get a control of. And next slide. I'm not sure if there's the next one after this. Okay, I guess not. Anyways, yeah, so just one last final note happened since then. I tested the batteries charging over the weekend. I pulled out a solar panel in the shed, had it blocking the shed door essentially, just to see how it would charge with one of the Gentech chargers, really. Due to my poor way of carrying the smaller block back indoors, I did experience the other short situation. And this is the lovely part about the BMS, because it did catch much of that. So for me, it was just an odd sound. And that's it. Any questions?
Thanks, Joel. Sorry about that. It said hit spacebar to unmute, but apparently on presentation, the spacebar makes it go wild there.
Oh, no worries.
I think we had a slide out of order. Let me just see if I can go back there. There we go. Courtney, are you on the line?
Yep, I'm here.
Hi. Did you want to talk about Makers Making Change?
Yeah, sure. Hi, everyone. And you can actually just pull the website up now if you'd like.
Okay.
Yeah, so my project, I suppose, is a little bit different than everybody else. I work for a not-for-profit organization, and we're a disability organization. And one of our programs or projects is called Makers Making Change. And it's all about connecting makers, so yourselves, with people with disabilities who want low-cost assistive devices. Assistive devices tend to have a markup of 300%, so they get really expensive really quickly. And of course, there's always the need for customization. No two people with disabilities are the same. So we just look for open source tech to try to make a community movement happen where we build a bunch of stuff together. And so if you look at my camera really quickly, this is just one of our devices that I pulled out really quick. And this is a bottle opener. So there's little ridges here, and that would actually grip the bottle. You put it here, and then just a little bit of strength, and you can hold that and opens bottles really easily. And that's 3D printed. So they have similar things like this at medical supply stores. They're easily $15, $20, but of course with 3D printing, we can make something like that for $1, $2, if that. And of course, the customization piece is really cool because everybody has different size hands, different needs, different grips. So yeah, so that's the project. I'll just kind of show you how to get involved if anybody's interested. So if you want to go to Assistive Devices for me first, Sean. Thank you. And so this is our project library. So we actually have over 100 devices on here. So anybody that's interested in requesting a device, they can go look through all this stuff and you can just kind of scroll down. Yeah. And there's literally tons and tons of things of all different varying needs, different text. Some are really simple, like you'll see the clear mask there. That's obviously a sewing project. And then you'll see other ones that are a little bit maybe more higher tech stuff. So there's all different kinds of things for all different sort of needs. Will you click on that happy face one? Yeah, I know it's a little funny to show a website on Zoom. But the cool thing about this is, so this was developed open source. So we tell you everything you need to make it. So if somebody needed this device, they go ahead and find it and they click and they request it, and it will connect them with makers, or at least post it, and makers can go on and see what people are looking for. And if you just want to kind of scroll down here, we give you everything you need to know about how to make it. So there's printing involved, we show you the printing files, the time, what skills you need, all of that information is there. So we can make it as easy as possible. Yeah, so all of that info is there. And as I said, I think there's over 100 different devices on there. The next thing I'll get you to click on, Sean, is the forum, and it might open up a separate window. But the forum, so if somebody were to request a device, it goes into our forum. So it opens up a separate page. To use the forum, you need to have an account, but it's a simple email and password sign up like most accounts. And we have all different categories. And so you can see, it'll come up in a sec. Yeah. There's all these different ones. So you'll see if you want to go ahead and click on requests down at the bottom. So anytime somebody wants a device, it'll go in there. So if you're just looking for a project, you want to, practice your 3D modeling and designing, maybe there's a utensil holder, or maybe there's some different ones to kind of match up your skills. So all those requests will go there. If you want to go back, Sean, I'll show you the next one. One of the really cool ones.
Sorry, go back where?
Oh, sorry, just go back a page.
Oh.
Yeah, thank you. One of the other cool things is a lot of times people have brand new ideas. So if you want to click on design challenges, yep. This is where all the ideas go to. So oftentimes people will have these ideas of things they know that they need, but maybe not exactly know how to make it. So this is where a lot of the collaboration happens. So you can just scroll down a little bit and you'll see there's all different kinds of ideas that people have, and you'll see there's lots of people posting, collaborating, talking about different ways. And this project is actually all throughout Canada and actually into the US as well. So you'll get all kinds of different collaboration on these projects. So if you're just looking for something design, or even just kind of curious about design in general, this is a really cool place to look at some different things. Yeah, so that's really great. And the forum's really where everything happens. It does happen from time to time that I'll get requests for devices or needs from our community that people aren't using the forum for whatever reason. They're given my name from somebody and they just send me an email. So I will also have those sort of requests that come in. So if anybody's interested in getting involved in the project, I'll put my chat down at the bottom, or sorry, my email in the chat at the bottom as well. Just if you're interested in kind of collaborating or getting involved in the community. Oftentimes we have requests for adapting toys for kids to play with. So just changing the switch inputs for toys. So some of it is very varying in what we need. We also might have some projects that I'll have all the materials for, but I just need somebody to make it for some of our more high-tech devices. So there's lots of different ways to get involved. And we have chapters, and we're also looking for people to join and get involved in the Halifax chapter. So if anybody's interested in that as well. And I think that's maybe everything, but I guess if anybody's interested in getting involved or just want more information, we have info sessions that happen on the last Thursday of every month. And so that's this week actually at 2, and they're just on Zoom. So if you wanted to go to our website and our events page, then all the info is there to get more info. And as I said, I'll put my email on the bottom if anybody wants more info on that. I think that's everything. I ran through everything pretty good, I think. But yeah, if anybody wants more info, please feel free to reach out.
Thanks, Courtney. I think we hosted a group
That's right.
fix here a while back,
Yeah.
fixing those sip and puff mouse devices.
Exactly. Yeah, and I literally always have those devices that need to be fixed or even built brand new ones. So that's a really good example of a device that's in constant need. So yeah, so we're always looking for people interested in you know.
Yeah, that was a lot of fun. Yeah.
Yeah, it was. Yeah, it was.
Thanks very much.
Yeah, thank you.
So let me see if I can get us back where we were here. Marcel, are you on the line? Anyone know?
Here.
Oh, you might be muted, Marcel. There you are.
See you.
Is your audio working, Marcel? No. Okay. We might have to do charades. Still can't hear you. Maybe we'll go to the next one while you get your audio, and then we'll loop back. Is that okay?
What's this? Can you hear me now?
Oh, there we go. Yeah.
There you go. Sorry, I usually have my microphone muted. The machine has several microphones hooked up, and I usually mute the snot out of the lot of them. So I'll be honest, I'd forgotten that I was going to present tonight. So, but I'm good. All righty. Anyone who's followed some of my stuff online, I started the process last year of making some block printed postcards from Halifax that were relatively well received. But for Christmas this year, I took it a bit further and did Christmas cards. Designed the cards from at home using Inkscape. Sean mentioned earlier, Inkscape is a graphics program. It's free, just my exact favorite price. And because it's available on any system, I can use it on my Mac, take files in and work with them on the Inkscape at the Makerspace. So I designed them at home, cut the blocks on the laser at the space, basically cut them out of a quarter-inch birch plywood. There's plenty of stuff in the space. And I used a 3D printed press that I found online last year, printed on my own machine at home, my own 3D printer, but it's really not necessary. You can do the same thing by literally standing on the darn thing to be able to do the actual printing. I mean, last year when I did postcards, I used an arbor press that I had, but I could have just literally stood on it and got the same quality. And so cut the blocks of the space, printed at home, used my inkjet to print on the cards, like the greeting on the inside. The pre-size stationery, it's stuff that comes 2 per 8.5 by 11 sheet, comes with envelopes, available at Staples. I had some lying around. I could have started from scratch and just used cardstock. The next slide, please. Top left shows you the results. My Christmas tree came out, the A lot of them, what I did was literally search online for images, photos, or art, and then by hand trace the outline on Inkscape and use very large, very fat pens, so to speak. The fatter the better, gives a much better. And the right-hand side, the stuff there, the warmest wishes, that was, of course, done on my inkjet printer at home. I can't block print quite that fine. They were well received by the friends and family I sent them to. Next slide, please. Here's the whole setup. The glass I got free from a local glass shop. If you can't find a piece of glass, a simple, flat, smooth tile, single tile from any home hardware or home improvement store would work just fine. It's just used for applying the ink to the roller, the brayer. The brayer is that little roller with the red handle. You put the ink on the glass, you rub it onto the glass with the brayer, and that just spreads the ink out well on the brayer. And then you take the brayer and push that onto the block, and you roll it back and forth on the block to apply the ink. You're not applying the block, the glass. Ink goes on the glass onto the brayer onto the block, and the block onto the card. That's the process. And the white thingy with the crank handle on the right-hand side of the picture, that is the 3D printed press that I downloaded originally and then up the scale. Actually, it's wider and longer than the original one I downloaded because I want to make bigger cards. Again, if you want to give this a shot, you don't even need that. You could literally put the block onto the paper, give it a good press all the way around, stand on it if you want to, and it'll give probably just as good a quality. Next slide, please. A fun and unique gift, cheap and easy. Once you've got the brayer, I think was the most expensive part of the entire process. I didn't have one. I wanted a proper one. You could get away with another method if you wanted to. Easily reproduced. I can create a bunch of them. No one complains or recognizes any errors in the final product. It comes across as a handcrafted, personally developed, personally printed item. So some of the cards are pretty, how would I put it, kind of smudgy. It didn't come out as sharp. It really still doesn't matter. They still come out quite nice. The really, really crappy ones I throw out. But in general, a handcrafted item you're not looking for, absolutely perfect. Like I said, the cons, tools materials took a little time to amass. The brayer was like the only thing I bought brand spanking new. I think I got it at, matter of fact, I either got it at, Michael's with a discount card. Buy anything from Michael's, go to the website. There's always a 30% discount on everything in the damn store. Either there or DeSeries downtown. I can't remember which one I bought it from. And DeSeries would get a discount too. The printing and selling the press, that took some time. Again, not necessary. Certainly takes more time than going and buying a box of cards. Let's take a look at that. And the block printing takes a couple of days to dry. It's still pretty smudgy, for lack of a better term. You want to lay it out and give it a good 4 or 5 or even 6 days dry before you start putting them into your envelopes to send them off. So it's not, oh, I got to do a card for someone tomorrow, but that's part of the fun. I could have done everything literally on my inkjet printer and printed the cards and been done with it, but it's not the technique, not the process that I want to try. I'm pleased with it, and I'll probably do it again next year. Next slide, you can just questions. Yeah, I'm good. I'll take questions at the end if you guys are good.
Very cool. Thanks very much.
No problem.
Bill, are you on the line? I think you are.
I am.
It's all yours.
Okay. So this is a sort of a joint project. My son-in-law built one of these shelf units that's got a clock embedded in the front. It's mainly a 3D printing and wiring undertaking. So you can see that in the lower right-hand side of this slide here. And it's 849 right now is what that says. Inside it has an Arduino Nano and a little real-time clock module to show the time. Worked great, looks pretty nice. He's a 3D printer, so he's got a bunch of his nice little prints on display there. But it keeps horrible time for some reason. Next slide. And so just a little bit more background on the process. It's a 40 by 120 centimeter piece of plywood that he got CNC'd channels into, just rough channels into, and printed these components that sit into those channels and all hook up together. And then the hard part was laying for each one of the segments of the clock, 9 neopixels, and wiring them all together, and then also additional neopixels into each one of the little square shelves for a pot light to highlight whatever's standing there. The fellow who built this, you could have seen that on that link I had on my first slide there. Did a really good job of designing this. It's good for holding the neopixels in place and good for routing all the wires, but it is a bit of a challenge. And my son-in-law is not well, he's better now, obviously, at soldering, but he was a beginner solderer when he started. Now he's at least intermediate level, if not expert. So he got that all assembled, next, and put together. Got the fronts on it, but like I said, it wasn't keeping very good time. So it was losing 12 minutes per week, which is crazy. I couldn't suggest to him what was wrong. He'd got this, he'd got the electrical components or the electronics components from me. And so I felt a little bit responsible for it. Looked at the fellow who designed this thing's code. There wasn't anything obviously wrong with that. Good battery, lots of power going to the whole thing, so I couldn't really figure out what it is. So I had the idea next of replacing that whole electronic arrangement with an ESP8266 based device, which I've been experimenting with quite a bit lately. They have built-in Wi-Fi, and so they can get out to the internet and get the exact time using the network time protocol, which is every serious computer in the world, like all the servers, the thing we're talking across with Zoom here to keep time synced, they sync up to the network time protocol. It's a stack of time computers that think they know what the time is, and at the very top of the whole thing are some atomic clocks in underground caverns, keeping time perfect to the to the nanosecond sort of thing. The particular device I used is a Wemos D1. It was pretty much a drop-in replacement to everything that was already in place there. It'll take a 5-volt supply. It works on 3.3 though, so I was a little worried about whether the output digital signals would be good to drive the neopixels, but wasn't any problem at all. They worked fine. So the top image there at the back is showing on my dining room table testing that it works. The green lights are simulating the however many there are little pot lights, and then that coil of neopixel, and behind is the segments. So I took it over to his house, and we jammed it in. It fit a little bit better than the Nano and the clock module were, because it's a little bit smaller probably, but it still was a little bit of a tight fit, but it worked right off, which was a nice surprise. And I also put in some stuff so that you can update it over the air, so you don't have to take the thing apart to do a software change. Just on your Arduino environment, you can find it on your local network and send it a new version of the software, and it'll load that in and rebuild itself. I've got a link there to the library that does that NTP code. Next. So it's working now. That's it back up there. The things remaining to be done are the design includes a photoresistor that looks at the ambient light level and adjusts the brightness of the clock. So I haven't hooked that up yet. ESP8266s are a little weak on the analog input side, and it's pretty easy to wreck that part of the chip. So I've got that set. I just haven't been over to get it put in. And then I was thinking you could do some fancier things because it's a internet based thing, and I've done some things like this before. I could put on a web interface to let you adjust the colors or brightness level, and even make it an alarm clock of some sort. So you set an alarm clock and it could flash yellow, or Pac-Man could run across the front of the screen. Who knows what? You could do all sorts of things. Well, I'm hardly taxing what that chip is doing. It's probably idle 99.9% of its time. I've used this same NTP client library on a couple of projects I'm doing at home that you might see next month. But apparently the manufacturers, the ESP8266, have their own library that's a little less weight. It's in there anyway, and so why not use it? So once I get that all finished, I think I'll put the software on GitHub and tell the designer of this that he could use this as an alternative. I think that is it. So yeah, if anybody's interested in the project and you missed those links, I can send them to you. And in a couple of weeks or so, I should have that source code up on GitHub.
Very cool. Thanks, Bill. That clock's really neat. I like that.
Yeah, he's got it in the background of his work from home, and
Oh, nice.
people were your clock's off by 10 minutes, so it was driving him crazy. So he had to unplug it until we got it hooked up. So it's on there, and thinking it's keeping good time now. So,
yeah.
And it hasn't blown up or anything, so I'm happy.
Yeah. Very cool. So I think that's everybody. We had Jordan, who was going to present something, but I think he's going to wait till next month. I think he might have dropped off already.
Sean, I have a small one in there.
Sorry?
I have a small one in there that I mentioned.
Small one where?
In the show and tell.
Oh.
I think I must have dropped it in at the end, thinking that it was in after yours. I moved it a second ago, but it must not have refreshed on yours.
Oh, okay. Is this it here, 29? Yeah.
Yep.
Looks like it. There we go.
That is the one.
Sorry about that.
No worries. Yeah, I won't take too long. This was just a very brief, just a couple small laser cutter projects that I did recently. Yeah, we've had the laser cutter for quite a while. It's a very popular piece of equipment, and a lot of fun things you can do with it. One of the questions we get a lot is, can you laser cut any metal with it? And unfortunately, the answer is no. Actually, kind of doing this out of order. Can you skip to the third slide? I'll do that one first. That's the one with the flask. Yeah. So our laser cutter cannot cut metal, but if you have something like this, that's a metal, like a stainless steel flask that's painted, you can etch away the paint. So I had a gift that I wanted to give someone, so I was able to throw that in the laser cutter and just use the raster engrave, so put an image, and it worked pretty well. It's a curved surface, but it's pretty minor curve, so it still worked out pretty well. You'd have issues if we don't have a rotary engraver, so you couldn't do like a round wrapping on a bottle, but if it's over just a small part of the curve, then it turned out quite well. So certainly a new thing we can start to try and do with the laser cutter. It's kind of amazing we've had it this long and not done much in the way of engraving paint on metal. So I'm pretty happy with that. And then the other one, if you go back a slide, Sean. Actually, just go back one more and I'll show the first picture. I don't know how many of you in Halifax are familiar with a local soap maker called Badmouth Soap. I have a few of these that I've bought at craft markets over the years, and part of it, the fun part of the soap is that it's named after various pop culture things. So I thought it'd be nice to actually show off what soap it is. So I decided I'd laser cut a small little holder. And if you go ahead a slide, so a few things I learned from this project and some previous, but kind of pointed out. A lot of the projects I do laser cutting are more functional, structural things, not artistic or kind of display stuff like this. So normally I'm very concerned about the size and the fit. And when you're drawing your model that you're going to laser cut, we typically use something called Inkscape, and you can either so the shapes that are on the screen, the red is you've filled it with red, or you can just have no fill on the object but set the stroke, which is the outline. The problem with that is depending on the width of the stroke, that adds to the width of your object, which when you're trying to do stuff that's going to fit together can throw it off. Rather than being a 100mm wide object, you get like a 100.4mm object. So normally I would just fill the object and use no stroke, and that way it keeps to the right size. But if you're going to engrave any lettering or do a raster at the same time, it kind of throws that off because all of a sudden it wants to raster that whole red section as well. So neat trick. Set the stroke width to 0, but enable it and use the view display mode of outline, and it will just add an outline to your object. So if you do any laser cutting, that's just a quick tip for helping you out. And if you go back one slide, Sean, I should have just put this image on the same slide. The soap of the day portion of that, I engraved, and I thought about just leaving it as an engraving and not painted, but I didn't go deep enough and I had moved it after that. So I decided I had put tape over the whole thing. So I just gave it a quick spray with spray paint. You can see that the paint bleeds a little bit from that. If you throw a clear coat on first before you remove that tape stencil, that'll seal it in and prevent whatever color paint you're going to throw on there from kind of bleeding out underneath the tape. So I already have a version 2 of this in my head. So I'm going to make a few design changes, and then I'll either deepen the engrave or do the clear coat in the paint. And then, yeah, back to that next slide again. I think the other one, make sure you save your files to the cloud before driving to the Makerspace. I designed this file twice, once at home and once at the Makerspace. Yeah, normally I'm good enough to save it somewhere in like Google Drive or Dropbox, but I had completely forgotten. Yeah. And if anyone's wondering what so it was a very quick design, so it wasn't too bad for me to redo it. The 2 larger ones, the soap of the day, and then the one with the nail holes, I did out of 1/8" plywood. And then the little one, I didn't think a full 1/8" was necessary to slide that paper in, so I just did some thin cardstock. I think it was actually a box from a can of Coke sitting on the shelf, so was able to use some scrap materials. And note to Marcel, I meant to put an IOU in the plywood box because I realized I didn't have any cash, but I forgot to put the IOU. So my next trip in there will be money for plywood there. So yeah, if anyone has any laser cutter questions.
Thanks, Adam. Yeah, if anyone has any questions, maybe we'll open it up for a few minutes. And if not, then if anyone wants to stick around, I can give a brief sort of 5-10 minute tour of the Makerspace if you're interested. As I said, we are doing a membership drive right now, so we're looking for members. If you're interested in becoming a member, best way to contact us is info@halifaxmakerspace.org. Usually people come out for a tour first, and we show them the space and the tools and all that kind of stuff before they make up their minds. We're all volunteers, so we can meet after hours and weekends and stuff like that. So it usually fits people's schedules pretty well. That said, are there any questions? I haven't been monitoring the chat at all.
I do see a question there from Joel about aluminum in the laser cutter. I think for our laser cutter, it doesn't have any effect at all. Ours is only a 45 watt CO2 laser. I think it is more to do with the frequency of our laser, although it definitely is low power. Anything with metal, you're going to need a lot more power or a different frequency of laser. There's one called a fiber laser that they generally use for engraving. So yeah, I don't think ours would have really any impact unless you're dealing with a painted surface on the metal.
Yeah, agreed. We tried that on some anodized aluminum, and it didn't absolutely nothing to the aluminum. Are there any more questions in the chat there?
I got two quick ones, Sean.
Okay.
First off, have we set or discussed how much you want to charge for the customized cribbage boards? The reason I'm asking, I'm thinking I would be more than happy to pitch those on my regimental connections. There may be a few soldiers that I know that might be willing to buy one where we can throw on a regimental cap badge. I've already got the one for the Fusiliers, but guess what? It wouldn't take much to come up with a nice one for the other regiments in town. But like a lot of things, if I'm going to pitch that, it would be really nice. I'll get you to send me some of the photos, but it would be really nice if we could actually tell them how much they're going to cost. And you don't have to answer me right this second, but that's something I'll need to know at some point in time is what they'll cost.
Okay. Yeah, I don't think we've really set a price yet. We're still trying to get the prototype out, and then I'll probably take a look at Etsy and see what comparables are.
Well, if you can send me a couple of the photos, I can at least
Sure.
pitch it up there and try to gauge interest. How's that sound?
That sounds good. Yeah.
And Adam, I'll have to get you to whether when we can sit down or something to go through your process for the outline for cutting your laser cutting your objects with zero kerf thickness. I'll need you to go over that with me in slow time because that's not how I do it. That doesn't mean what I'm doing is right. I'm always interested in finding other ways to do it.
Yeah.
And I think I got a
Yeah,
gist.
it was a pretty quick thing. It was essentially just setting the stroke width to 0,
Okay.
where you would normally set the stroke. And then in the view menu, where's the
Okay, now are you setting
Try
the
to peek
stroke to 0 in Inkscape or once it's already into the laser software?
in Inkscape?
Okay.
In Inkscape, yeah, all of these settings were in Inkscape. And then when I'm in the Inkscape, I go to the view menu, display mode, and then click outline. And that way, at least I can still see the lines.
Right. So what happens when you feed it to the laser printer? Like what settings do you do? And I'm asking if I know. Not that.
Oh, actually, you know what? I need to double check that actually accomplishes what it. Yeah, that might. I might still need to, at least for working and able to work and make it functional, being able to set the line 0 so that I can do my process of accurate positioning and measuring. It works. I have not yet actually done that on the next to the laser cutter, so I'll keep you updated.
Sure. And again, I'm in no way calling you out. It sounds really interesting.
Oh yeah, no, I've had times though where just the working process of setting the stroke width too small and then you zoom out and all of a sudden it disappears on your monitor, whereas the view display option of outline makes a line that's visible regardless of how zoomed in you are, which is handy.
Again, I'd love to learn more about it and try to find a different way another way to try some of the printing. I do a lot of cutting and I do a lot of boxes. So getting the pins and the holes to line up and not be too sloppy.
Yep.
I'd love to find an easier way than manually setting each pin and each slot, which is what I currently do.
Yep.
Okay, cool. Yeah, whatever. Thanks.
Cool.
That's all I got, guys.
So quick read through the chat. It looks like that's all the questions. There is a tip from Mike Wiktawi. I'm not sorry if I pronounced that wrong. about dry moly spray will mark stainless steel when laser etched. I'm not familiar with that, but we'll have to
Done
look
some
that
reading
up.
on it, but haven't tried it in our laser cutter as of yet.
Oh, okay. Yeah, we'll have to try that one. We're always looking for new ways to use the existing tools we have, and even after like 6 years or whatever we've had the laser, we're still finding new stuff that we can do with it, surprisingly. So it's a great tool. Yeah, so I think that pretty much concludes the show and tell for tonight. Like I said, the next one will be the last Tuesday in March, same time. And if anyone wants to stick around in a minute or two here, I can do a quick tour of the makerspace. Or if you wanted an in-person tour, you could email that info@halifaxmakerspace.org, and we can arrange for an in-person tour. But that said, anyone who wants to go now and has already seen the space or whatever, feel free to drop off. Thanks for coming. And if anyone wants to present at the next show and tell, we're always looking for new projects. So we'd love to hear what you have to say. Thanks, everyone. So I'll just give that a minute to drop out, and for anyone to drop out who wants to, and then we'll do a quick tour if there's still people here.
Really good attendance tonight. Yeah, like up there was like 25 or plus people tonight. That was really good.
It was. I wonder how good it would have been if I'd posted the correct link.
People thought it was secret, so that's why they came in. No, well.
Yeah.
Thanks,
the count was 25, but we had a couple of people who were here that had gone, and then down to 23, and then it went back up to 25.
Oh, okay, great.
It's still better than twice our normal number for this.
So I'll start with a little tour here. I'll try and keep everything in frame. I think we have some people.
Sean, you might want to stop screen sharing so that we see you full screen and not just your browser.
Oh yeah, good idea. Where is that? Stop share.
Don't click the leave button. I do that.
Come on.
Acknowledge.
There we go. Just got to get rid of. There we go. All right. So this is the front door here. I'm in the front, what we call the front room. The front room is a kind of multi-purpose type room. We've got some sewing machines, some leatherworking stuff. There's a tiny bit of metalworking stuff out here for some reason. Arts and crafts supplies and a printer, and that's our infinity mirror up on the wall. That was an old art project. We have a shelf of various projects, mostly 3D printed, laser cut stuff. Whenever someone does a new technique, we encourage them to stick something up on the shelf there to kind of share what they've done and encourage other people to, to learn a new technique. Down here's the hallway to the electronics room, which is kind of a mess right now. We're overdue for a cleaning, but we got lots of parts, soldering stations, oscilloscopes, bench power supply. This also doubles as a classroom in more kind of social times. We can fit 6 or 7 people in here maybe, when it's all cleaned up and we sort of move stuff around. Then continuing down the hall, little kitchenette. We keep it stocked with snacks and drinks and stuff. Silk screen press up on the wall. There's a little tiny vacuum former. There's Adam Savage. He's in here a number of places. A little memorial to the space shuttle pinball machine that we killed to make a different pinball machine. There's a bathroom, storage, not much to see in there. But we got a bunch of material that's kind of up for grabs if people are looking for material, wood and plywood and plastics and all kinds of stuff. This is the wood shop. It's fairly small, as you can see, but it's a fully functioning wood shop with table saw, band saws, sanders, miter saw, drill press. Those are kind of the traditional things, router table down there. And then the non-traditional aspects are, there we go. That's a large format CNC mill called a Maslow, which will do a full 8x4 sheet of whatever. So that's a computer controlled mill. You know, carve out signs, or we had one guy do a really cool stage display. There's photos of it. That was for an electronic dance music festival in New Brunswick. He did the whole display here. And there's our small CNC mill in the corner, which will do like 15 by 11 inches roughly. Oh, it'll do this kind of thing here. There we go. I don't know why that's backwards, but it'll do that kind of thing. Wood shop. And then the best for last is I'm working on the laser today, making some notebook covers. That's going to be a Boba Fett notebook cover, just out of oak plywood. This is the laser here. Have some Beauty and the Beast notebook covers in there tonight. There we go. That'll do 20 inches by 12 by 1/4 inch thick. We keep all our pizza boxes from across the street. We do acrylic. Got a stack of 1/4 inch plywood here, Baltic birch plywood. We do a lot of foam board. So it's a pretty versatile machine. And then the room I'm in here is called the smelly room. Mostly because of the laser. When you cut acrylic, it really stinks. we have it vented, but it's not 100%. There's our shelf of filament for the 3D printer. And there's the 3D printer itself. It's a Prusa i3 Mark III. It's a real sort of workhorse of a 3D printer. It tends to work pretty good, even though we have a bunch of amateurs, and I include myself in the amateurs using it. We have 2 or 3 members who know it really well and keep it really well tuned up so that people like me can just come in and use it. This is there next to my head for scale. That's about the size. This was printed on the printer, so that's about the size of the prints you can get on it. It's quite a big printer. Does great prints and is really reliable. The filament up on the wall belongs to the Makerspace, and people just use it at will, and they buy a new roll when they feel they printed about a roll's worth. Then that's another little 3D printer tucked in the corner there for when the big one's in use. So that's pretty much that's the quick version, 5 or 10 minute version of the tour. Like I say, if anyone does want another tour, you know, in person or has questions, best way to reach us is info@halifaxmakerspace.org, and we can that goes to like all 6 directors, so we can we generally get those emails fairly quickly, and we usually have a quick turnaround on answering any questions. So that's pretty much it, I think. Unless anyone has any questions, you feel free to ask them now.
Don?
Yeah.
Are those empty spools up on top of the printer?
Yeah, I collected the empty spools, hoping that the next person who goes and buys some new ones will take them and recycle them. I should put a note on them to that effect.
I'll be in the neighborhood tomorrow. I wasn't planning on stopping by Eureka Tech, but if the timings work well, I'll swing by, pick them up, and I'll drop them off. They'll pay us like 50 cents a piece, which is better than at least throwing them in the garbage.
Oh, yeah, for sure.
And I don't know if anyone missed it or not, but last week they had a 15% discount on all their filaments. So I picked up a couple for myself. And for what it's worth, if anyone out there is also interested, when Eureka Tech occasionally has what they call random color filament, and they make their own filament. So you'll get spools with, the color's not quite consistent, or they're developing a color up. Like I had a spool that's pure white now, that the top end of it was all black, was the start of the production of black. I mean, long story short is if you want to play with filaments, their random stuff is like $14 a spool. Perfectly good quality, just random colors, and a great way to stock up for some stuff to play with. Anyway, if you put all those empty spools in one spot, Sean, I'll take a swing by tomorrow if I can, pick them up and move them out of the space.
Okay, yeah, I'll pile them all up on the printer there.
Perfect.
For anyone interested, that was Eureka Tech in Lower Sackville. They're a local supplier of filament. Sorry, Larry, you had a question?
May I ask a question?
Yeah.
So you have a mill, right? A CNC mill?
That's right, yeah.
Do you know what the precision on the mill is?
I don't know, but I mean, I make cribbage boards on it completely repeatably. So like, I don't know if you were a machinist, you might be sort of worried about the precision, but if you're a woodworker, I could say that it's precise enough for whatever.
I'm wondering, has anyone used it to make printed circuit boards?
As far as I know, there's only been one person use it to make a circuit board. But it was a very kind of simple circuit board. It was basically like a rain detector, a bunch of fingers interwoven, so that when the raindrop breaks it can detect that. I don't know that anyone has printed any really fine traces on it yet. But I think it would probably be capable of doing that. I think the only maybe tricky thing might be ensuring that the board was perfectly level.
Yep. And the machine that runs it, I take it that you could put your own machine as USB based, is it?
No, actually, it's an old serial cable, I think.
I think
and
it's
a Windows 30.
parallel.
What's that?
I think it's
Oh.
parallel port, but I could be wrong.
Which was the old printer?
So RS-232.
RS-232.
Oh, maybe
Ar-
that's not it.
Yeah, maybe it is.
It's
Is
a
it-
really wide, really wide cable.
Is it a wide ribbon cable, is it?
Ribbon cable?
That ribbon cable?
I don't think it's a ribbon cable that comes out of it. No.
The Centronics parallel port would be would be like if it was using a parallel connection. It's quite a large connector.
Right.
This RS-232 would be either a DB9 or a DB25. It's a smaller, typically metal shell connector.
DB25 meaning 25 pin?
Yes.
Yeah, so I think that's likely it. It's been
Two rows of pins, one on top of the
years
other, and they're offset by half.
Yeah, it's been like 3 years since I've actually looked at it, but
Okay.
it's plugged into a 32-bit Windows machine.
Okay, I was going to ask you next. So it's running like Windows 7 or an older version of Windows?
It's an older version of Windows. It's 7 or older. I'm not sure exactly which. Yeah.
Okay, cool. So you wouldn't have any, would there be any difficulty if, for instance, I brought my own machine and I was running Linux on the machine and I had to organize the interface to it, or is the interface a little iffy?
I don't, so the software that we have, I think only runs on the Windows 32-bit.
Yeah, that's the problem. The software I want to run runs on Linux.
Oh, okay. Yeah, I don't know what would be involved with that. So you want it to drive the mill from your computer.
Yes. Yeah.
Yeah, that usually requires a special Linux kernel because you have to. It's a particular real-time kernel. I forget the exact name for it, but if you're looking at Linux CNC, which is ultimately older versions of Linux, but of a distro, but it does happen to mention. I think it's RTAI or something like that, but the kernel type.
Yeah, well, I have access to a Windows and Mac program called Fusion 360.
Oh, yeah.
And also the program I was thinking about using for driving a CNC, but it'll depend obviously on the CNC. But the one that I am somewhat familiar with, not super familiar with, is a Linux program that it'll run on any Linux core. I think the one you're thinking about is what's called RT Linux, real-time Linux, which has been deprecated for some time now. Most of the modern cores, anything Debian-based anyways, actually does have real-time core built into the standard Linux systems. But anyway, I know that's cool. I appreciate you telling me about it, and I would like to come some evening and take a little personal glimpse around. I'm a little busy this week, unfortunately, at work, but I could take you up on your kind offer maybe next week.
Sorry, I can hardly hear you.
I don't know where that is. Can you, so my microphone is not right here. I was saying that I would like to come and actually see the space in person.
Okay.
But I'm a little busy this week. So I was wondering if perhaps I could take you up on your kind offer next week.
Sure. Yeah.
Yeah, I'll send a note along to info at the Makerspace email address.
Okay. Yeah, sounds good. It's probably worth noting we have another CNC in a box. Adam, do you remember what that one was called, or Bill?
Yeah, that's that common hobby one. What's that called? Cutco or something? It's not Cutco, but something like that. Shapeco, yeah.
Yes, that's it. Yeah. So we got one of those in a box. We haven't gotten it running because we have two other ones that we haven't really been using. But if there was interest in getting that one running, especially as like a PCB mill, then I think we could probably find a space to house it.
Yep, I'd be very interested in having a go at that, and I could probably come up with some a machine or something that we could use to drive it with without too much trouble. So yeah, so I'll talk to you next week if that's okay.
Yeah, that sounds great.
Larry, I put the I think it's the right manual. I put a link to the manual in the chat here.
Okay.
I believe that's the one we have. It's got a big orange box on it, right, Sean? The controller?
It's black.
Oh, They have one that's USB based, but I think we have the other one. So
yeah, we have the older version. They came out with a USB version, although the guy who donated it said that it's conceivable we could upgrade the one that we have to USB. I don't know what would be involved in that. I assume it'd be a fairly serious undertaking, but it's certainly a possibility.
Is it parallel driven now? Is it?
but
I think so. It's like I say, it's been like 3 years since I looked at the back of that machine, so I'm not really sure.
That would be interesting to have a go.
Yeah.
See what we can do with it. Cool. I appreciate the show and tell today. It's really exciting and very interesting. My interest is mostly in radio and building stuff for radio.
Oh yeah.
Cool. I'm studying for my ham course. I'll have to give you a call if I run into something.
Well, I even volunteered actually. If there was some interest, I've taught the amateur radio course many times. So if there was interest, I'd be more than willing to do it. At one time, I don't know if I'm still qualified, but I used to be a ham radio, used to be the amateur radio examiner. So I could give the exams too, but I'm not, you're supposed to keep the qualification up. And since COVID, I haven't even looked at it. So I don't know if I still am or not.
Yeah, right now, there's a gentleman, Al, his last name, teaching the basic ham course. He's down in Annapolis Valley, and he's running an online course that's like 250 students across the whole country, which is working really well.
Cool.
Down the road, of course, I'm in Halifax, he's in Amherst, but there's people from as far away as BC. I think there's a couple international students.
Wow, excellent. That's
So
a good idea.
Yeah,
Wish I thought of that.
there's so much stuff that'd be great if we just did it by Zoom and not bother with the damn. In you can cover a lot more ground, make it a lot more convenient if you do it that way. But we'll get
Yeah.
there.
It's true.
Still have to pass a Morse code requirement for those?
Not
Uh,
anymore.
No,
Oh.
no. The basic course is a pass mark of 70.
Mm.
If you do 70% and a 5 words per minute Morse code, or a pass mark of 80, you get what's called with honors, and it gives you access to the HF bands.
Yeah. It's quite easy. I mean, the Morse code part is actually, everybody was so afraid of it, but most of the amateur radio stuff I do, I use Morse code, and I actually really enjoy it. But I've been a ham since I was 9, so
Oh, okay.
maybe easy to learn Morse code back in those days.
I'll be 60 before I become mine, so I'm at the other end of the spectrum, literally.
I actually flunked the test when I was 16. I couldn't be bothered list the rules and stuff. I found too boring, so I concentrated on there was some physics and the Morse code, and that was what I liked.
Yeah. That's cool. And Bill Morrow,
Mhm.
are you ex-RCMP perchance?
No,
No. Just wondered, are you the chap that we're talking about the military insignia?
no, that was Marcel.
Oh, that was me. I'm retired now, but 37 years in the Army Reserves. Most of that with the Princess Louise Fusiliers here in Halifax.
Cool. I used to be in the RCMP in B Division in Newfoundland, long time ago. Oh, I was just curious.
Hmm.
Anyway, it's nice talking to you guys. Really nice to meet you, and looking forward to next week to be able to see the thing in person.
Super. Well,
Thank
I
you,
think
Dean.
that's as good a place as any to call it a night. Thanks everyone for dropping in, and hopefully you'll drop in for the next one.
All right.
Thanks, guys.
Bye.
Everybody. 3, 2, 1. Bye.